This conference will now be recorded.
Hello, everybody. Jordan Girth here with the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 207. Hope your meteorological fall has started off well. Today's presentation, though, Mastering the Mesosector, Coordination Considerations for GOES Mesosector Imagery. I'm so glad to have Melissa Huffman, the meteorologist-in-charge of the National Weather Service Southern Region Operations Center, with us today. A discussion will be facilitated by Chris Smith, the GOES-R liaison to OPC and WPC. Just a few reminders, as you heard, the session is being recorded. We ask that you please mute your microphones and make sure your webcam is off if you are not presenting or asking a question. There will be opportunity to ask questions after the presentation, and we ask that you post your questions in the chat and we'll field them in the order they are asked. If you have not signed in using your name, perhaps using an office account, please note your name when asking a question in the chat so we can follow up if necessary. We're looking for future presenters for our Satellite Book Club. Yes, we've done 207 of these, but we want to do 207 more. Maybe you have a presentation from the National Weather Association that you just gave, or for the EMS meeting that's coming up. We'd love to incorporate it, even if the central focus of it is not satellite, but perhaps it uses satellite. So there's a link in the chat that Emily has posted, and the training team can help create training material that may be unavailable or point you to materials you may be unaware of. Ross Van Til, the Office of the Chief Learning Officer, can help with that. I'd like to thank the OCLO, the GEO and LEO programs, Kashad, Emily from our Tower S team, our presenter, our facilitator, and all of you for being with us today. Without further ado, let me give Melissa a little bit more of an introduction. She's the meteorologist in charge, as I said, at Southern Region Headquarters Regional Operations Center in Fort Worth, Texas. She's spent her entire NWS career in Texas with previous duty stations in Corpus Christi, Austin, San Antonio, Houston, Galveston, and Midland, Odessa. I'm starting to wonder if she's banned from the rest of the US. Melissa has a Bachelor of Science degree from the University of Nebraska-Lincoln in Meteorology-Climatology and a Master of Public Administration degree with a specialization in emergency management from the University of North Texas. Melissa, we're glad to have you today.
Thank y'all so much for having me. I'm just going to keep my camera on for this brief introduction, and then I'll turn it off and then back on again for questions. But thank you, Jordan, and thank you to the SBC team for having me. I'm really excited to talk about this. I think it's important to understand the role that regional operations centers play as it comes to coordinating GOES Mesosector imagery, because this is one of the frequent interactions that the regional operations centers have, not only with field units, but also with the senior duty meteorologist. We do have 6 regional operations centers around the United States, so this is not just CONUS, but also OCONUS as well, with Pacific and Alaska region. And so you may be interacting with your regional operations center at a point in time for making one of these requests. So today I wanted to take some time to kind of talk about the under the hood, how these requests get made, who they get directed to, and then also provide some coordination examples that I think are pretty interesting. So with that being said, we'll go ahead and get started. I'm going to turn off my camera, and Kashad, we can jump into the next slide. Perfect. So just as a little bit of background here, we do have basically a way for us to organize requests that come in for these GOES mesosectors. So it's usually identified by a field unit, and this could be a river forecast center, this could be a center weather service unit, or this could be a weather forecast office. And so when this local field unit identifies that they need this resource, they'll direct that request to their regional operations center. And that's primarily the first indication that additional coordination is needed is when these requests are received by the regional operations centers. Now, the regional operations centers also work to coordinate these requests. If there are, let's say, multiple requests received, we only have so many mesosectors that we can provide across the CONUS. And so this is a way for us to help do a little bit of horse trading and negotiate where maybe the center point for that mesosector imagery may be located. The ROCs will then funnel that up to the senior duty meteorologist who actually schedules the movements. And then they also provide a coordination support outside of the ROCs. Now, Kashad, if you could click This is basically how requests are funneled, is the field to the rock to the senior duty meteorologist. But we also have this extra layer here of our national centers who enter their own requests, and they enter those directly to the senior duty meteorologist. And sometimes those requests may not necessarily capture an area that a field is actually looking towards. So your regional operations centers and your senior duty meteorologist will engage in additional discussions to meet the needs of all of the entities involved. And so sometimes there's a little bit of compromise, but I want to take a moment to talk about how we go through and we enter these requests so that the senior duty meteorologist can schedule these MDS movements. So Kashad, if we could go to the next slide. I want to take a moment to talk about the Mesoscale Mission Manager, the MMM. And so this is how your regional operations center is actually entering in the requests that you have. So if you look on the left-hand side there, all the regional operations centers can look at their request, their proposals, and then they can actually enter in a new request or proposal. Before they even get to that stage, though, they can see what's already been entered with the active meso locations that's shown on the globe there on your screen. So we can see the 2 mesosectors allocated to GOES West, and we can also see the 2 mesosectors allocated to GOES East to see where they're already located. Now, they may be at their normal resting location, or they may have already been tasked by a national center or a previous request that was made by a regional operations center. We can also, using this, see how long that request is in effect for. And that can be pretty important because sometimes the requests are made for longer than the actual window in which it's needed. And that's where some additional coordination goes in. So not only are the regional operations centers looking at spatial coordination, but there's also temporal coordination that goes along with these requests. So Kashad, if we could go to the next slide, we're going to talk about how we prioritize some of these requests, because again, we only have so many mesosectors. We've got those 4 mesosectors that we can coordinate, or we can combine mesosectors and get some additional high resolution imagery over the same location. So we can either get 60-second or 30-second imagery over requested areas of interest. But not all requests may be honored as submitted. And there's a certain priority level that's assigned to the request that helps us figure out which request should be given greater priority. But if there's no request, the sectors are going to remain in their default locations. And so the right-hand image was just a GOES East image that I pulled just to kind of show what some of this imagery may look like to end users who are viewing them outside of AWIPS online. So if we jump forward to the next slide, we'll actually take a look at some of the priorities. There are about 25 priorities. And so basically the higher up on the list a priority is listed, the greater the priority that it has. Now these are the top 10 here, and I've highlighted in orange just kind of roughly what the main intent behind that priority is. So you can see number 1 there is that SPC high or moderate risk, but there's also priority given to volcanic ash eruptions and plumes, the SPC enhanced risk, active hurricane warnings or watches from the National Hurricane Center or the Central Pacific Hurricane Center, events with national importance. So these would be things like your Democratic or your Republican national conventions, the Olympics, any kind of large high visibility event. You also have your SPC extreme fire weather, SPC slight risk, or WFO severe thunderstorm tornado watch or warning, your SPC elevated or greater critical fire weather outlook, a WPC high or moderate risk of excessive rainfall, or your National Hurricane Center or Central Pacific Hurricane Center, 40% or greater chance of tropical cyclone development. So you're probably hearing a lot of terms coming out in this list. So those Storm Prediction Center thunderstorm risk outlooks really drive a lot of the priority within this top 10 list, but there is also a consideration given for National Hurricane Center or Central Hurricane Center products, as well as that Weather Prediction Center high or moderate risk of excessive rainfall. Now going into kind of the second half of the list, if we move to the next slide, you can see that you've got even more Storm Prediction Center criteria. You've got WPC, you've got that Weather Prediction Center criteria, but you also have some things that I'm not quite sure the field recognizes that actually qualify on this priority list. And I really wanted to highlight the low instrument flight rule conditions, the LIFR conditions, widespread at large or medium FAA hub airports. And so this is something that I'm not sure, particularly as we're heading into the cold season and we are looking more at fog and stratus events, particularly for terminals that could be close to maybe marine areas or our high volume areas. You can absolutely request GOES Mesosector Imagery for that. We also have winter storm warning, blizzard warning, ice storm warning, snow squall warning as a priority. That's listed on number 14 there. And dust storm warning, dense smoke advisory, dense fog advisory. So just kind of keep in mind, it's not just national center outlooks that drive requests or qualify on this priority list. You can request it to support your operations, and these are operational mission priorities. So I just want to draw attention to that because I'm not quite sure how much visibility there is on that. But what happens if we have competing requests? What happens if we're getting multiple requests for the limited resources that we have? How do we make that work? Well, that's where the additional coordination that the regional operations centers and the senior duty meteorologists get involved with. So if we go to the next slide, how do we begin to handle this? So even when these conflicting priorities are submitted, resource allocation to lower priority requests can still be accommodated. Well, how does that work? Well, it actually starts by just communicating. Just because you submit a request doesn't mean that that's how that request is going to be scheduled. And so your regional operations center may reach out to you. The senior duty meteorologist, if you work for INCEP, may also follow up with you. And we actually have a series of conversations on determining the center location for the request, on determining the hours of the request. We've actually coordinated requests where we'll just focus on the temporal window of concern, and then we'll submit another request to move it to a different area because the actual data needs are occurring at 2 separate times. And this also can occur with research interest in advance of significant events. So there may be a lot of attention on an event that's occurring where there's actual weather happening. So there is some balancing too for research and operational needs as well. And I want to take a moment to just kind of provide 2 examples of some coordination that's actually occurred. So if we'll go to the next slide here, we'll talk a little bit about some of the active wildfires that occurred in New Mexico earlier this summer. So for those of you who may have caught this on the national news, Ruidoso, New Mexico had a series of wildfires that produced significant and large burn scars across portions of central and southern New Mexico. And so this is actually a look at one of those wildfires. You can see this was a very violent event that actually produced repeated rounds of burn scar flash flooding. And this was something that the regional operations centers, as well as the weather forecast office in Albuquerque, New Mexico, as well as El Paso, Texas, were working to provide partner support on. In fact, Albuquerque, New Mexico, and the El Paso office were deploying meteorologists to provide on-site support using satellite imagery. That's not the focus of this. We're just talking about coordination, but these GOES mesosectors played a huge role in decision support services. If we move forward to the next slide, we can look to see some of the aftermath of burn scar flash flooding that occurred near Ruidoso, New Mexico. I want to point out that it does not take much rain to produce this type of flooding. So you can see here basically by how this vegetation is laying that high flows moved through this area. When you have a wildfire, it essentially cooks or burns that topsoil and creates a hydrophobic surface. And you can get violent flash flooding with rainfall amounts as little as 1/4 of an inch. Sometimes this rain can already be on the ground before you see significant radar returns depending on the coverage. And so this really lends to the importance of having that GOES mesosector imagery to support these flash flood warnings that are needed to alert not only first responders, but folks who are at risk of this flash flooding. So that's just a little bit of background on the importance of having this imagery. But if we move forward to the next slide, we're actually going to take a look at an event, some of the coordination that happened to support this New Mexico support. So on the left-hand side is the Storm Prediction Center's outlook for June 26, 2024 that was valid as of 12Z. And I want you to notice that we have a slight risk of severe storms across portions of northeastern New Mexico and essentially along the Front Range, which is pretty common during the summertime months. On the right-hand side is actually the archived GOES mesosector requests that were in effect at 12Z. And what's pretty normal for the regional operations centers is to come in and see the requests that the national centers have already outlaid. Now, the weather forecast office in Albuquerque was deploying a forecaster to southern New Mexico to provide burn scar flash flood support. And if you click one more, Kashad, we'll actually take a look at seeing there's actually a gap in southern New Mexico. So we're on the edge of that mesosector, and the office was requesting for it to be moved. So what do we do now? We have a significant operational need. The priority is not necessarily listed as high as that Storm Prediction Center outlook. So now we need to have some additional conversations to figure out how we can support not only the severe convective threat, but also that burn scar flash flood threat. So if we move forward one more, a lot of this coordination actually ends up occurring in Slack. And so if you're curious on stalking this kind of satellite coordination, going into the Senior Duty Meteorologist Slack channel, you'll be able to see a lot of this interaction from the regional operations centers. So I put a note into the Senior Duty Meteorologist chat to see if it would be possible to move the location. The Central Region Operations Center got involved as well, wanting to make sure that the greatest risk area for that severe thunderstorm outlook was covered. And so we actually went back and forth for a bit to basically negotiate where this new center point would be. And you can see the result of that on the right-hand side of the screen there in that pink area. So we were coordinating the GOES Mesosector Imagery, so that not only were we able to cover southern New Mexico, but also make sure that we covered the Nebraska Panhandle, which was one of the main concerns that the Central Region ROC had as well. So moving forward, I've got a satellite loop in here just kind of showing some of the visible imagery that was used. The Albuquerque office, as they have a deployed forecaster, they are monitoring the satellite imagery, and they actually will begin texting first responders and notifying them that, hey, we could be dealing with another burn scar flash flood event, and this is all based on this behind the scenes coordination to give them that resource so that they are able to provide that life-saving information. Now I want to transition from kind of an active warning scenario to a larger event that had some research implications as well. So if we go ahead and transition into the next slide, we'll talk a little bit about the April 2024 solar eclipse. And this is something that obviously was a multi-region event. So not only did we have portions of southern region, central region, and eastern region affected, but we had research groups that were interested in capturing information from GOES mesosectors. And so local weather forecast offices actually began requesting coverage a few weeks ahead of the eclipse for this GOES mesosector imagery. And so this is just an example of one request that I had gotten. This is from the Austin San Antonio office. And so they were basically talking about, hey, this is what we're looking at. Is there a way for us to pre-position this? As you can imagine, in an eclipse, and we saw this in the 2017 eclipse too, across central portions of the United States, is we have a lot of people moving. So not only do we want to figure out, hey, if there's cloud cover, are people going to be moving ahead of the cloud cover? But it's also April, and it's April in portions of the Southern Plains. So there's also a risk for some severe weather associated with this as well. How do we go ahead and adjust this? So this began some initial conversations. As you can imagine, the requests varied wildly on what the center points were that each office was requesting because they were looking at it from their perspective. That's when the regional operations centers, as well as the senior duty meteorologists, got involved to figure out how do we come up with a plan that's going to capture the path of totality while also supporting what could be potential convective coverage needs. So moving forward from that, we actually stood up a series of conference calls. The senior duty meteorologist was wonderful. They put out a proposed plan that we actually presented to Southern Region and Eastern Region field offices to help get their approval and make sure that everyone was well briefed on what the coverage would be for their forecast areas. And with the plans that were coming up, we actually ended up being able to get 30-second coverage for portions of the path of totality because of that overlap, which was also really critical as well because there were portions of Texas that were dealing with inland stratus during this event. And so that provided just even more temporal resolution to the data they were receiving. So if we move forward to the next slide, You'll actually be able to see in very, very tiny print, and I apologize, but I wanted to try to fit everything in this email on what the agreed upon plan was. And so this was something that actually occurred with a series of discussions in the weeks leading up to the April 2024 eclipse to make sure that we were not only representing the operational needs, but we also wanted to include support for research interests as well, because an eclipse is not an event that happens every single day. And so this just kind of lays out what the plan was, how the mesosectors would be moved and adjusted, and then recognizing that, hey, there could be some other operational concerns that come up with this. How are we going to handle that? And so that was a larger coordination piece that supported both these operational and research interests. And if we move forward to the next slide, we'll get to see this wonderful picture of everything laid together of the path of totality. And I think this is just a really, really wonderful image to kind of highlight all of the different conversations that happened to make this imagery possible. If we go forward one more slide, we'll be able to take a look at some resources. And I believe Emily will be posting some of these links in the chat. This is the Mesoscale Mission Viewer, and this looks very similar to the Mesoscale Mission Manager that I showed. However, that's what the rocks are submitting requests through. You're not submitting requests with the Mission Viewer, but you're able to see what requests are out there. And I think this is a really valuable tool for the field, because sometimes we'll get requests in and there's already a mesosector out over an area that covers pretty much what the original field request is. And so this is a good situational awareness tool. If you think you need it, you can also see how long that mesosector request is in effect for. So again, this is a publicly viewable webpage, but this is a good situational awareness tool. And then if we move forward one more slide, you'll be able to see, this is a resource that I actually kick out to the field when people are not quite sure who they or where they want their center location to be. This is actually a page where you can plug in your sample latitude and longitude to figure out what view you might get, because that's one of the most common things from a regional operations center perspective that gets left out of these requests is where do you physically want that center location to be for your mesosector. And that's what really opens up the coordination, particularly if we have multiple requests, is getting that. So that lat long is actually really, really critical when we're looking at actually getting these set up. So moving forward, one more slide. I just want to provide some final thoughts. So Kashad, if you want to just kind of tab through to open up each of these. The coordination of the request is most successful when involved user groups know what they need. So one, being aware of what mesosector requests are currently out there. Moving forward to the next one, what areas must be included in the domain. And so this, hopefully your center location drives that, but really be thoughtful about what are you truly looking at. If it's just the marine areas of your CWA, or if it's maybe the entire CWA, maybe you're looking at a larger state, depending on the support that you're providing, but be very intentional about what that request is for. And then what's the time window of concern for data collection? Because if we have to coordinate, that's going to be a follow-up question that I ask, is really truly what are the hours that you're looking at here? If you expect convection, do you expect convection to occur through that entire period, or is it a smaller window? And then what are those data needs that you have for a local area? What's the priority here? Are you using this to simply have a nice to have, or is there something that's really helping you get ahead of a warning situation similar to what we had with the Albuquerque and El Paso offices? And then kind of providing some additional thoughts here, if you want to hit one more click there, that there is room for collaboration with overlapping field and research requests. We saw this with the April 2024 eclipse, and I think that's where some of this coordination really benefits, is we want to make sure that as many people as possible can get that data as it's available. And then the final thought here, clicking one more, is that coordination for significant planned events can and should occur well in advance of an event. And I imagine that the regional operations centers and the senior duty meteorologists will be talking quite extensively as we head into World Cup planning for 2026, since we will have so many stages within the United States that will likely require advanced satellite monitoring. And with that, I believe my next slide is my closeout slide. So I just want to thank y'all for reaching out. I think, Kashad, if you click one more, my email will be on there in case anyone has any follow-up questions. Oh, nope, it's the preview. Never mind. So I just want to thank y'all for giving me a few minutes and letting me talk coordination, and I will stand by for any questions.
Thanks, Melissa. That was a really great presentation. A lot of insight into the mesoscale, how to request them, and some great resources. I encourage the attendees to stay on for discussion, including the forecast offices and regional headquarters, and change your camera to active camera from the default view if you're comfortable. In a week from today, on Thursday, September 26th at noon Eastern, Aaron Jacobs, Senior Service Hydrologist from WFO Juneau, Alaska, will discuss utilizing remote sensing and NASA Sport Land Information System, Alaska, to improve flood and landslide situational awareness from heavy precipitation. And I encourage attendees to contact the TowerS team, Kashad Bowman or Emily Maddox, for questions about the Satellite Book Club or for configuration of satellite products. And I encourage attendees to put their questions in the chat or verbally indicate if they would like to ask a question. Steve Miller, looks like he's first. Go ahead.
Yeah, hey, thanks. I didn't see where I could put like one of those virtual hands up, so I just did the old-fashioned way. Thanks, Melissa. That was a really informative talk, and appreciate all the information. I wanted to clarify with you that the audience, when you say you can request, I'm assuming that's talking to those field offices, particularly the National Weather Service and the others, right? That's not like a cooperative institute scientist or somebody like that. Is that right?
Yes, and that's a great point. Is for operational requests, when I'm referring to, I guess, the Royal U in this sense, it would be those river forecast centers, those center weather service units, and those weather forecast offices.
Okay, great. A follow on to that really quickly. I was just in a workshop this week with the Federal Aviation Administration and keyed in on your comment about item 21, I think, on your priority list, where it had to do with the fog and visibility, I think, and near airports and things like that in the winter time. Can the FAA or some proxy to the FAA, for example, make a request through this process?
We haven't typically supported FAA requests, but that would likely be something they would need to coordinate with those embedded meteorologists at the Center Weather Service units to support that. So there may be some external coordination with those user groups through those defined channels at the Center Weather Service units.
Okay, thank you.
Yeah, if I could just jump in and add a little bit. There is a Google form for non-NWS research requests. Those are, of course, the lowest priority or close to the lowest priority. I put that link into the chat there, and that is an option. Not so much probably for the FAA, but if we have scientists that are looking to potentially conduct a study that would benefit from higher temporal resolution imagery, there's a possibility to submit it through that manner.
Thanks, Jordan.
Alrighty. And I did have a question about the priority list and submitting requests. Say if there's an SBC high risk day, is that usually automatically switched to a certain mesosector where the high risk is, or will you at Southern Region still have to submit a request for that event?
So usually if we're dealing with a significant outlook like that, the Storm Prediction Center will coordinate with the senior duty meteorologist, and that's usually already in place. The day one outlook, I believe, drops around sometime 60-ish. And so usually once that day one outlook comes out, that's typically when the Storm Prediction Center will submit a request like that.
Great, thank you. Another question, just thinking about how this list of mission priority was put together and representing the Ocean Prediction Center, is there ever any coordination to add or change the order of the list or anything like that in the future, or is this pretty much set in stone?
I think that would be a better question. I saw Rob Handels on here with the senior duty meteorologist group. I think that would be a better question for the SDM. I'm not going to say anything's written in stone, but they're the ones who manage that priority list, and I would imagine that's a better follow-up question for them. And there's Rob now.
Yeah, we actually had an initial list when we put these MDSs in place, and we've revised it once with the whole MDS team that includes the regions, the centers, a number of headquarters folks, and we all come together and try to decide which ones are the highest priorities, which ones are the most pressing and urgent concerns that could save lives. So we do revisit that from time to time. We have occasional meetings, and if there are concerns about the list, feel free to bring them up to any one of us, and we'll propose your idea to the broader group. I should emphasize, because there's always a lot of questions with research requests, and are they truly the lower requests, or are, and that's not entirely true. When you're in like a critical weather day or an enhanced caution event, those would be lower in priority than an operational request. But what we're trying to do is balance the NOAA operational concerns with the NOAA research parts of our mission, and support the research community as well. So we try to say one for operations, one for research in a normal day, and only in the most critical of days do we sort of reject the research request and prioritize operations first.
All right, thank you. Another question I had was, how long, do you have a suggested time? I don't know what works out the best for how long a mesosector usually lasts in terms of hours. Is it a day? Is there a preferred, time window that works out the best?
We typically find that most field units will they'll submit a request either morning or midday, and then they'll try to run it out through 12Z the next day. That's why I really want to stress that it's important to know what window of concern you have for what you're looking at, because that can ultimately influence the time that you request for. A lot of times, though, we get the request in, they're trying to turn it around really quickly to get that coverage already in place. So 12Z is typically used as a default, but my best practice would be what is it that you're truly looking at? What's the window of concern there, and use that to inform the request that you make. And there's nothing that says that you can't extend that request, but have some intention behind the request that you're making.
Thank you. And Jordan, you have a question.
Yeah, thank you, Chris, and thanks again, Melissa, for your presentation. Excellent, and appreciate everything you do down there at Southern Region Rock. One of the things that, as I go to forecast offices, I hear quite frequently is something along the lines of, from forecasters, I've got a lot going on. The satellite imagery is great. I don't know if I necessarily have the time when the weather's getting active to get that mesoscale request in. What do you say to that, perhaps, and what do you think can be done to improve the experience for our folks in the field?
So I think not waiting until you get into the event to figure out how to build that into your workflow. I think part of that comes along with your seasonal readiness. So if you're an office that frequently experiences severe convective weather, then maybe this should be a part of your seasonal readiness training on, is a GOES Mesosector a priority for us within operations? Who requests it? Kind of do some of that internal organization before. But to be perfectly honest, most of the requests we receive are in Slack. And if you can take 15 to 20 seconds to just type out, hey, SR Rock or CR Rock or whoever your supporting rock is, we would like to request this GOES Mesosector for this lat long through this time. That's really all we need for the request. The coordination examples I provided were a little bit longer in time, and there was a little bit more coordination that goes in, but usually it's pretty straightforward. So if you can take just a few seconds to type that out, the regional operations centers pretty much handle it from there. But again, if you have concerns about that, this is a part of your seasonal readiness. And since we're getting ready to head into winter, we talked about how winter was one of those events on the priority list. Maybe have some internal discussions within your unit on, if we want to make one of these requests, what does that look like coming from our office?
Thank you.
I did see in the presentation a couple times, without a request, the mesosectors remain in their default locations. For the users on the call, do you know where those default locations are located, just so people are aware?
Are you asking me for the center lat long?
Or yeah, just a general geographic area, like is one on the East Coast, or do you know where those boxes usually are situated?
So there's typically one that's kind of over the mid-Atlantic, and then there's one that's, I think, over the Ohio River Valley, as rough locations. But my SBC folks, and Emily, you can correct me if I'm wrong. I have Emily sitting here with me in my office, but generally those locations. And I see Rob popping on to help provide some info.
Yeah, pretty much those are focused for aviation interests. So it's covering kind of that New York to Atlanta corridor in the east with GOES Meso 1. Meso 2 is focused on the Chicago, Atlanta to Denver, Dallas corridor, I think. And then in the west, you've got sort of that one I know less perfectly well, but we have one that's centered over Anchorage, like Alaska, and then one over the West Coast. So those are pretty much the defaults, again, mainly to cover all the aviation and population interests in those times where it's not requested.
Thanks, Rob. That's very helpful. I'll leave a minute for any more questions in the chat, or if you'd like to come on camera. Otherwise, I think I can turn it back to you, Jordan. Thank you, Melissa.
All right. Well, that was wonderful. Really appreciate that. Thank you so much, Chris, for leading that discussion. And of course, Melissa, once again, thanks so much for that presentation. As Chris has already been mentioned, the Satellite Book Club continues each and every week. Next Thursday, September 26th, we're going to hear from the Senior Service Hydrologist at the Forecast Office in Juneau, Alaska, about improving flood and landslide situational awareness from heavy precipitation. And that's been an active topic. If you've been watching the news, there's been some landslides up in Alaska. So should be a great presentation to tune into. In the meantime, if you have any questions about satellite imagery products, the Satellite Book Club, AWIPS, all three or four of those combined, Kishad Bowman and Emily Maddox are great. Really appreciate Emily for being on location today for this Satellite Book Club seminar series. You can find their email addresses there. And of course, just like you can find your rock, you can find the Tower S channel on Slack as well. We'll wrap it up there for today. Really appreciate everybody joining us. Thank you so much for your time once again. And thank you so much, Melissa and Chris, for helping us extend our book club seminar to another session. Take care, everybody.